So again, just to say that we usually don't have a lot of data, and even more important, we don't have a lot of label data. This is something that I guess a lot of you already know, and it's actually one of the big challenge to apply machine learning in finance. Another challenge, you will not be able to see, I guess, both texts, but basically those texts are the minutes from the FOMC meeting, so from the Fed, where they decide their interest rate change. So there was one in September and one in January. Forget to read all the text. It's actually identical, almost identical. The decision is the same. But if you try to predict, for example, the market, obviously it's a hard task, but the market completely reacted differently. So there is actually a noise in the labels if you are using this kind of labels. And the reason why is because the Fed chair made actually a comment during the Q&A session after the meeting in January, and this is why the market basically changed the view, the perspective for investors, and basically it makes it very noisy from a machine learning point of view, which means that the noise could come from either you don't have enough data in terms of input, but you cannot have all the data in the world as input. So like to predict the COVID-19, for example, almost impossible to have everything. So the noise, so the signal to noise ratio, it's very low in finance, and it's something to really keep in mind, because this is not usually what we've got, for example, with a cat, to predict a cat and dog. The signal is actually very strong. So we kind of know for sure that what is a cat and what is not a dog. So there are kind of two fundamental reasons why it's hard to apply machine learning in finance. So we don't have a lot of data, and the labels usually are very noisy. So, okay, how do you apply machine learning? So in finance, but usually what is a typical way to do it? So I guess it's similar to what was actually presented a bit before. So usually we start from rule-based, and then we build some features with some knowledge from the business, from the domain, and so on. We start to have like some machine learning model to use the features to predict what we want. And we may end up, in the end, more on the deep learning side, more to do like end-to-end model, where basically we want to automate the feature engineering part. But the issue with the end-to-end model, it doesn't work well when you don't have a lot of data. So that's one fundamental reason why we don't see a lot of deep learning model in finance. And it's not just in finance. If you look, for example, for self-driving car, the way that they make those models, they are actually doing like the paradigm of divide and conquer. So there will be one model to predict what is in front of you, one model for another task, and so on. So it's not like from raw input to what the output. And also, I will argue, like perhaps something which is completely different to the previous presentation, that feature engineering is actually something which is massively underrated. And the reason why I'm saying that, it's deep learning model, it's actually, you can call it representation learning. You want to learn some features, but if you already have a lot of knowledge about your domain, you should try to inject this knowledge rather than to let the model try to figure out from the data. And I think like it's especially the case in finance, because perhaps more on the market side, and there are perhaps more very specialized type of things. But nevertheless, like if we already know what is a good representation, what may be a good feature, why not using it directly? It will help the model at least to start with your task. So with this in mind, so this is kind of solely my own proposal to apply machine learning in finance, and it starts to always start with the simple model, and actually to start with rule-based. Because rule-based, it could be like if you do asset allocation, 60-40 allocation, it could be whatever, you just predict to buy something, you just predict to randomly, this kind of thing. The reason why is because the signal-to-noise ratio is very bad, and so to beat actually dummy baseline, it's very hard. And it's something which is almost never presented when you look at research paper. You see like perhaps something very advanced compared with something which is almost advanced, but it doesn't make a lot of sense for me. So you should always start very small with like something which is dummy and to see if you can already beat that. And to do feature engineering, to bring some finance knowledge, so you may want to use a beta coming from the capital asset pricing model or something else, whatever you want, and to apply very simple machine learning. So naive Bayes, for example, is something which is very good in terms of model. The reason why is because it's very robust. So you don't need to do a lot of hyperparameter tunings and so on in order to find a good, okay model. So this is to say, okay, can we basically solve the task? And to put how good can we be at that specific task? Then you can, okay, iterate. So this will be the usual process, iteration. So you bring more feature engineering, something which is not mentioned enough, but also to do some label engineering. So rather than to predict regression, to do a regression, perhaps to do classification, or perhaps to try to predict a residual over an existing model rather than to predict the raw value, which is something which is actually usually very efficient, and to look at manually the errors and to try to understand where the model is failing at. And this is in fact more what I will call task definition refining. And it's actually something which was shown before, like they started from the supervised approach and then they switched to an anomaly detection, so an unsupervised setting. All the projects that I work with are always the same, like you start with something which you think it's a good idea, but your end model is always completely different. Actually, you are more learning what is the task that you should do, that rather than trying to have a model to be good at the task. And I make like a point about to use simple machine learning and so on. It's not to say that deep learning is bad. And I think to your questions that you ask, what could be in the near future, my personal view, it's actually deep learning could be very good more when you apply it to increase your training set. So there is like a recent trend coming from academic research, which is more to enrich or to create new training data, which is, I think, particularly useful in finance. So there is a paradigm of using unlabeled data. So you may have a bunch of data that you don't have any label, and you may want to use some knowledge from it. So this is the approach, the paradigm of the self-supervised learning, which is used by BERT, T5, Electra. You've got a lot of model, GPT-3, for example. You can also use an approach to synthesize your data set. So you could use like generative adversarial network or something else to try to create new training data in order to be better at your own task. You could do also data augmentation. And for NLP, usually something which is kind of underrated, I think, because back translations, so you've got your text in English, you want to translate it to French, then you translate it back to English. This is actually a very efficient way to have a model to work when you don't have a lot of observation. Empirically, it is. Or you can do like more advanced modeling, so multi-objective training, so multitasking, try to predict several things at the same time, or to do like multimodality, so you could have, let's say, market data and also news in the same time, this kind of thing, but this starts to be a bit more complicated. And all of those, actually, the last part, so actually I read, I don't know if you saw, like Stanford published like an AI index report. And if you look at them, they state something like 9 over 10 state-of-the-art approach model are actually using this kind of approach. They always enrich their training data, so it's very good to have a maximum efficiency. But I will argue that the best benefit for that, for us in finance, it's more like it makes it possible to solve some case where we don't have a lot of data. And this is something which is, I think, underappreciated. I'm not saying that we should start straight from that. We should always start very small and to try to build to see, okay, if we are actually making some progress scientifically speaking. But this is definitely something which is to keep in mind. So I guess this is perhaps my own view of, okay, what could be in the near future. And just to illustrate further this point, Stanford launched a new initiative with their Center for Research on Foundation Models. You could check out, they got like a lot of free resources there. It's actually very nice, and it's all about self-supervised learning. So it's all about trying to learn what are the capabilities of GPT-3-like models, especially in terms of few-shot learning, which is when you don't have a lot of training data. And it's actually a very big initiative that they launched last year. Another illustrations coming from more healthcare. So it's the use of synthetic data. So just to show that this can work. I'm not saying that it's obvious to see where it will work in finance, but they were able to improve on the, I think it's cancer detection using X-ray. So they actually generated some fake X-ray using a gun, and they show actually that they managed to have a better performance for their task. Another thing, which I think kind of wrap up to see like this, or consolidate is what I was calling like leveraging additional data. So NeurIPS, for those who may not know, it's the, I guess the largest AI conference, academic conference. So where you will see all those models like coming from Google, DeepMind, whatever, Stanford, Mila, and other like research institute. And there was like a full workshop around data-centric AI. So the point here is that over the last decades, the focus was on improving the model. So I don't know, having like a convolutional neural network on computer vision to build some ResNet in order to improve some of the issues that those models may have. So basically focusing really on the model, but the recent trend is certainly not to focus on, okay, the data. How can we improve the data that we've got? How we can have more data? How we can leverage some data coming from another task or without a label as well? And they got like actually, I think, some nice ideas there. And also, I think it's definitely the trends, at least in the next 5 years, it's to rather than focusing on the model, which can be solved with AutoML platform, but more to focus on, perhaps more on the data. So, okay, to wrap up with some takeaways. So the first one I will mention, it's especially in finance, I think, we need to build a bridge between the experts in AI, I prefer to say machine learning or data science, and in finance. And the reason why is because you need to redefine the task. You need to change everything, and actually you need to build actually a bridge between those two very specialized knowledge, and the bridge may not be the same as the one that you think. So it may not be a bridge for cars, but maybe a bridge for both, just to illustrate a bit the point. Also, something which, since there are a lot of noise in finance use cases, simple is good. It's not a bad thing. Simple is good because it's very robust. So you will not have, you will have less the issue of overfitting or the variance coming from a machine learning perspective. And so it's always good to start very simple for that. And it's actually very hard to beat simplicity. And the last point I want to make, it's perhaps a general point, not necessarily in finance, but when we talk about machine learning, so computer science, even if it's within computer science, there is something practically which is very different, is that you don't know in advance what does work. So when you do like programming, okay, you may start with some business requirements. You cannot know for sure if you can make it or build a solution for that or not. But when you talk about machine learning, you have actually no clue what is a good performance that you will have. So you may end up with 99.999%, or maybe you end up with 10%. You don't know what is actually how good it is. So so that's why it's very important, I think, more practically, you need to prototype ideas. You also need to keep researching, to have perhaps sometimes some moonshot project, and to look at what also is happening in the research fields. For example, up to very recently, it was very hard to do document classification, at least using deep learning models. But nowadays, actually something which is possible with the new the efficient transformer models, so such as the reformer, longformer model. I give you just some names, but which make basically it possible to process some very long sequence, which was not possible before that. And the image here is also to illustrate that you don't know what in advance does work. This is the perceptron model, which was built in the 1958. It's one of the first neural networks. It took, so to come back at the beginning, up to 2012, roughly, to see that this is working. Of course, there are a lot of things which have been added to make it work, but still, that's very important to prototype your things. That's it for me. Thank you.